Happy viewers. Myself, Dr. J. Abdul Bari, working as Associate Professor in the Department of Civil Engineering. Today, we will be discussing the topic suspension bridges, which is a fascinating and essential structural forms used in the modern civil engineering. The overviews are, in this presentation, we are going to cover the history of bridges, comparisons of suspension bridges with other types of bridges, their components and characteristics, and how the loads are distributed in the suspension bridges. We will also look into all the types of suspension bridges and what makes them unique. Let's see the definitions of bridge. A bridge is a structure which is built to provide passage over the obstacles like rivers, road or valleys. The design and materials of bridges will depend upon their purpose and the nature of sites where they are built. Some of the history of development of the bridge. Historically, bridges began with simple materials like tree, trunks and stones. In the Roman period, it has been introduced as an arch design around 100 BC, which helped distribute stresses efficiently. In Asia, around 700 AD, long arch bridges allowed water and boats to pass the underneath. Fast forward to the 1900s, we saw the use of wood followed by steel in 1920s. By the year of 2000s, we began using prestressed concrete, using steel and materials that revolutionizing bridge constructions. Now we will look into detail about suspension bridges versus other type of bridges. There are various bridge types, each suited to different spans and site conditions. Beam bridges are short and simple. Arch bridges, which works well in valleys due to their load distributing shapes. Truss bridges uses triangular frameworks for stability. Cantilever bridges handle longer spans. But for the longest spans and striking aesthetics, suspension bridges stands out. Some of the components of suspension bridges. There are 5 basic components. First, the main cables that can carry the primary loads and are made from the high strength steel. Then we will have the towers which supports the cables and transfers the load to the ground. Anchorages at both the ends secures the cables and are embedded deep into the ground. Suspenders or anchorage connects to the main cables to the deck. And finally, the deck is where the vehicles and the peoples are travels. This is the components of the suspension bridge. So we have looked into the main cables as well as the anchorage, decks, piers and abutments. So suspenders are the vertical cables and the main cables are look into these figures. So the characteristics of suspension bridge. So suspension bridges are known for the long span capabilities, sometimes over 2000 meters. They are more flexible, making them resistant to certain loads but also sensitive to vibrations. Their open design is aesthetically pleasing, but they can expensive to construct and maintain. Here we can able to see the main cable is in tension members, whereas the suspenders are also in the tension members. But in few cases, the members will be in the compressions and few cases the members will be in the bending characteristics. So this is an example for the bending characteristics. Here the girder spans between the suspender ropes will tend to bend because of the loads acting on the suspension bridges. You can see in this diagram the fill beams as well as the girders will be carrying the bending characteristics. Some other characteristics of the suspension bridges are, in addition to the flexibility, suspension bridges can be designed to sway slightly, which helps with the dynamic loads like wind or traffic. But the same features can also make them vulnerable to oscillations if not properly damped. And we can able to have the huge anchorages, that is dead weights in the suspension bridges as one among the characteristics. In this diagram we can able to see the weight has been acting in the downward directions. If the weight has been acting in the downward directions, the normal loads or normal reactions will be acting in the upward directions. Because of the normal reactions, we can able to have the frictional force which is acting opposite to the direction of the force acting. So the suspended bridges is unstable, and stiffening presses which are all needed for the stability and lateral stiffens is used in the suspension cables. If stiffening structure is not provided, we can able to see the bending action of the suspension bridge. The load distributions in the suspension bridge. There are three major types of loads, that is live load, dead load and environmental load. The live loads includes cars and pedestrians and are calculated based on the standards like ASTO. Whereas the dead loads are the bridge's own weight like cables, decks and towers. These are transferred through the suspension to the main cables and then to the towers and to the anchorages. In environmental loads, which includes the wind and the earthquakes, which can be critical especially for the long span bridges. The load distribution in the other types of the bridges. Unlike the suspension bridges, other bridges like beams or truss bridges distributes loads more directly through the supports or triangular frameworks. This difference in load path significantly influences the design and materials. Some of the types of the suspension bridges. There are few types of suspension bridges. Simple suspension bridges are basic and flexible. Stiffened suspension bridges include elements to resist bending and swaying. Self-anchored suspension bridges conduct the cables to the decks instead of the ground, suitable for the areas and poor soil.